Today we're talking about parallel and perpendicular slopes and how we can compare them and what they can tell us as we look at different slopes. So our essential question, or what we're trying to discover today, is how do I use slope to determine determine if two lines are parallel or perpendicular. So we're going to look at slope, we're going to compare them, and then by looking at the two slope numbers, we'll be able to tell what that is. So we look at line A and line B. So I'm going to label line A and line B. And the idea is that we're going to discover the slope for each one and then go from there. So when we look at line A, and I draw my little triangle from point to point, and we go up 2 over 1. So the slope for A is 2 over 1, or 2. The slope for B, and I'm going to draw the little triangle, is again up 2 over 1. So slope B, so M sub B, we say M sub B, or slope B, is again 2 over 1, or 2. So when you look at these two numbers, they are the same. So that makes two lines are parallel if they have the same slope. So that means that slope 1 equals slope 2. That's all we're doing. And you can tell as you look at the picture that this line and this line, they appear parallel, but we want to verify it by looking at the actual numbers for the slopes. So then we talk about perpendicular lines. And perpendicular, remember, means the two things intersect at a right angle. So this is perpendicular. And we're going to look at, again, line A and line B. Here's line A, and here's line B. So line A, if I make my triangle, is up 2 over 1. So slope A is 2 over 1, or 2. And it's positive slope because we're going up. But when I do line B, and we pick points again, so I'm going to draw my triangle down here. This time the slope of B is down 1, right 2, which stays negative 1 over 2. So now when I compare these two, what do we notice? Two lines are perpendicular if their slopes are opposite reciprocals. So that means that they have to be upside down or flipped. So that either means that the slope of number 1 is negative 1 divided by the slope of line 2, or M1 times M2 equals negative 1. Another way to think about this is that if I start out with AB, then I end up with negative B over A. And if we use that same analogy for parallel, A then I have A over B and A over B when they're parallel. So parallel slopes are the same, perpendicular slopes are opposite reciprocals. So let's look at some examples. Determine if these two lines, so CD is a line that connects those 2 points, and EF is between the points E and F, and we're trying to determine if they are parallel, perpendicular, or neither. So this means they need to be the same. They need to be opposite reciprocals or neither. So we start by looking at points at the slope for CD. So the slope for CD is y2 minus y1 over x2 minus x1. This is x1, y1, x2, y2. So that's negative 8 minus a negative 18 over 6 minus a negative 9. Change your negatives to double negatives to positives. And we get 10 over 15, which is 2 over 3 when simplified. So then we look for the slope of EF. x1, y1, x2, y2. That's 11 minus 5 over 0 minus a negative 9. That's 6 over 9, which is 2 over 3. The slope of CD equals the slope of EF. Therefore, and these 3 little dots mean therefore, they are parallel. So that's all we're asking for. You have to be able to compare the 2 slopes and determine what kind of relationship those lines are going to have once they're graphed. So now let's look at number 2. Again, I have the line CD. Let me undo that, not draw through the points. The line CD and the line EF. And we know which points go where because of this statement right here. So first we start with the slope of CD. And we label x1, y1, x2, y2. So I have negative 10 minus a negative 18 over negative 14 minus a negative 6. Change the double negatives to positives. That becomes 8 over negative 8, which is negative 1. So then we look at slope EF. x1, y1, x2, y2, 9 minus 7 over 6 minus 4. That's 2 over 2. That's 1. So if you don't know exactly, remember that it said that the slope of CD times the slope of EF could equal negative 1. So CD is negative 1 times positive 1. That equals negative 1. Therefore, they are perpendicular. So that's what we're doing. We're taking the 2 slopes and we're comparing them to determine the relationship that those lines will have after they're graphed. So, again, the slope of CD equals x1, y1, x2, y2, 9 minus 6 over 2 minus 6, that's 3 over a negative 4, which is the same as negative 3 over 4. And then we have the slope of EF, x1, y1, x2, y2, negative 9 minus a negative 6 over negative 9 minus a negative 4. Change double negatives to positives, negative 3 over negative 5, which becomes positive 3 over 5. So when I compare these two, I can multiply them, remember? So the slope of CD, since they're not the same, I know they're not parallel. So then I can say the slope of CD times the slope of EF should equal negative 1. Negative 3/4 times 3/5 equals negative 9 over 20. Remember your fraction rules, multiplying numerators and denominators, which is not negative 1. Therefore, it is neither. The slope of CD is using x1, y1, x2, y2, negative 9 minus 12 over 8 minus 1. That's negative 21 over 7, which is negative 3. The slope of EF, x1, y1, x2, y2, is 19 minus 7 over 2 minus a negative 2. That becomes 12 over 4, which is 3. So the slope of CD does not equal the slope of EF. Therefore, not parallel. The slope of CD times the slope of EF should equal negative 1. Negative 3 times 3 equals negative 9, which is not negative 1, therefore not perpendicular. Therefore, it is neither. Now, you don't have to go through all those steps. If you can look at it and realize that these two aren't the same, so they're not parallel, and you can realize that they are not opposite reciprocals, then that is not perpendicular. But this section right here is the justification or proof that your answer is correct. It is a self-check to make sure that you have the right answer by looking at either this or this. All right, let's look at another one. So we're just continuing with the same idea. So I have the slope of CD, x1, y1, x2, y2. That should be the first thing you always do, is to label your points with their coordinates. Negative 13 minus 8 over 9 minus 16. is negative 21 over negative 7, which is positive 3. Then we have the slope of EF. x1, y1, x2, y2, negative 5 minus a negative 17 over negative 13 minus a negative 17. Double negatives become positives, and that is 12 over 4, which is 3. So when I look at these, slope CD equals the slope of EF, therefore they are parallel. So you'll see me use these symbols for parallel and perpendicular as a shorthand. Just a way to identify. Remember the 3 little dots? It's not mi vita loca. It's therefore, and the 2 lines represent parallel. Okay, last one. So we have the slope of CD. x1, y1, x2, y2, 9 minus a negative 7 over 13 minus 9. Double negatives become positive. That becomes, oops, let me fix this. That was negative 7, not 17. So that's 9 minus a negative 7 becomes positive, and 13 minus 9. So that is 16 over 4, which is 4. Then we have the slope of EF, x1, y1, x2, y2, 5 minus 3 over 9 minus 17. That's 2 over a negative 8 equals negative 1 over 4. So they're obviously not the same, so they're not parallel. So then I want to look at, does the slope of CD times the slope of EF equal negative 1? So that's 4 times negative 1 over 4. This is actually over 1, and that equals negative 1. Therefore, they are perpendicular. And that is how we use slope to determine whether lines are parallel or perpendicular, either by identifying the slope straight out of the equation or from the points.